Hello everybody, I am Keisuke Ariyoshi, a seismological researcher at Jamstack. Now I'll introduce the usage of ocean bottom pressure gauges for earthquake disaster mitigation. As you know, Japan is surrounded by subduction plate boundaries causing megathrust earthquakes with large tsunami. In southwestern part of Japan, megathrust earthquakes and tsunamis are anticipating along the Nankai Trough. There are historical documents that suggest various ruptures patterns of historical earthquakes. For the disaster mitigation from the next megathrust earthquakes, it is important to clarify possible scenarios of earthquakes and tsunamis and their preparation process. On the basis of the possible scenarios, developing tsunami early warning system is also important. The DoNet is a submarine cabled real-time seafloor observatory network for the precise earthquake and tsunami monitoring. The DoNet is able to replace maintenance and extend while operating and have a redundancy for the internal or external observatory network component failure. We installed DoNet 1 in Kumano-Nada and DoNet 2 in Kisuido. DoNet has 51 observatories with strong motion, broadband sensor, pressure gauges, hydrophone, and differential pressure gauges. The system brings subsea telecom cable technologies to fit for the high reliability requirement for 20 years seamless observation. We also installed 3 borehole observatories, connected them to DoNet for real-time monitoring. After the installation, magnitude 6 earthquakes was occurred. Magnitude 6 earthquake was detected from the DoNet and borehole observatories, which is the first large plate boundary earthquake since the 1944 to Nankai earthquake occurred. Seafloor cluster deformation is also detected by hydraulic pressure gauges. We also detected slow slip event close to the Nankai Trough by borehole pore pressure sensors. The change of pore pressure is very small, about several hectopascal at most. Hydraulic pressure gauge is also useful to monitor tsunami inundation for early warning system. After the 2011 Tohoku earthquake, prototype Japanese government has installed SNet of Tohoku region. This network is just under the Oyashio current path. Before the 2011 Tohoku earthquake, a prototype inline cable network detected a large tsunami before arrival. Recently, Tokyo University installed additional observations. YOB has shown this figure. So our goal is to monitor the plate coupling on the basis of data assimilation. However, seafloor observation is suffered from ocean fluctuations. So JAMSTEC installed another cable network of Shikoku, which is just below Kuroshio current path. Combining hydraulic pressure gauges of the cable network with campaigned observation PICE, we can detect the time delay of changes between sea surface height and bottom pressure. JAMSTEC has also installed another cable network of Hokkaido. After the 2003 Tokachi earthquake managed about 8, cluster deformation due to post-seismic slip was detected from seafloor hydraulic pressure gauges. However, there is a temporal change during the cluster deformation. So we investigated the sea surface height and depth profile of salinity and temperature. After that, we concluded that this temporal change is due to mesoscale eddies. This is a schematic view of integral study on the seafloor pressure data. Recently, we attached TD sensors to underwater TV of drilling vessel Chikyu and get depth profile of temperature with high time resolution for several months. So my conclusion is seafloor pressure data is classified into cluster deformation, ocean oscillation, instrumental drift, and other factors. To extract each component, we need share observation plans with other research fields, such as seismologists and ocean resource engineers. This is our team of Jamstack. So I'd like to collaborate various types of researchers and worldwide. That's all. Thank you for your listening.